section. So what we're going to look at next is something called, I'll turn the light off now. Seriously. Hey, come on. Time velocity graphs.
Isn't that velocity time?
Yeah, well, here we say time velocity. I can explain a bit more of this. Sometimes people call them different names. Sometimes people call them time speed or speed time or something like this. The most accurate name is time velocity graph, because whenever you give the name of a graph, you usually put what's on the x-axis first and what's on the y-axis next. So for example, this is called time velocity graph because here will be time and here will be velocity. So for example, if you had another graph like if this was x and this was y, what would it be called? XY graph. So that's why it's time velocity and not velocity time. Although if you said velocity time, I'd still understand you. So it's not a big thing. So let's have a look. Like I said there, time velocity, as the name suggests, time this way, velocity this way. Okay. Time velocity. This graph is extremely useful, and this graph has lots of information in it. Come on, are you ready to write? Are we all writing this? You doing this?
Yes.
So at the beginning, what's my velocity? What letter?
0.
No, what letter?
U.
U, at the beginning. Initial, yeah. So let's say there's U. And then as time goes by, what happens to my velocity?
Increase.
Let's say, for example, it increases
Acceleration.
to V. So this here would be me starting at U and increasing my velocity or my speed to V. Let's look at everything this graph has to offer for us. Suppose I was to calculate the area here.
Distance.
It would be the distance, but let's prove it. So the area, there's two pieces to add together. What's the name of this one? Rectangle. This one? Triangle. So what's the area of this rectangle? Yeah, UT. Yeah. And what's the area of this triangle? A half the base by the height. Now the height is V minus U. But what does V equal? U plus AT. So what does V minus U equal? AT, right? So I can put that in there. You see what's happening? So I get area equals UT plus a half T AT. So equals UT plus a half AT squared, which equals?
S.
So we have our first result. The area on the graph will represent the distance traveled.
Do we have to do all of this because we can do it simply?
If I write it down, you write it down.
No. I don't.
No, when you do the questions, no. This is the proof of it. So for the questions, you can now know that the area equals the distance. Yes.
The triangle.
Yeah.
From U to V, or
Yeah, from U here to V here, yeah.
it's what? Half T?
The area of a triangle is a half the base, so a half T, multiplied by the height, and the height is V minus U. From maths class, if this was a point, what point would it be? It'd be the point 0, U. I'll write a different colour here. Well, I'll write here. 0, U. And if this was a point, what point would it be?
0, 0.
No, V. So what's the slope of this? Remember the formula? y2 minus y1 over x2 minus x1. So v minus u over t minus 0, so that's t.
Oh.
Does this look familiar? If you go back to last class, this is the definition for A, acceleration. So now we have a second result. The slope equals acceleration. So where's u? Here's u, here's v, here's a, here's t, and what's the s? The area. So every single thing you need is on this graph. And let's have a look at some time velocity graphs. So the reason you need time velocity graphs is because in reality, when things move, they constantly change their acceleration. They might start at rest, they might go fast, they might travel at a constant speed, and then they might slow back down. So it's always changing, and that's why this is so useful. Okay? So for example, maybe somebody can tell me what this graph represents. So what speed does it start at? It starts at rest, and then what happens? Accelerates to a top speed, and then when it hits the top speed, immediately decelerates back to rest.
Could it be like something thrown up?
Actually, you would think that, but no, because that one's actually a little bit different. I can show you that now in a second. If you throw something up in the air,
Yes.
it starts at a positive speed, and then it gets slower, 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 comes to rest, and then it starts to come back down. So actually, it's still going to be a straight line. Let's have a look at this one. This is a common one. Starts at rest, accelerates to maximum speed, keeps this speed, and then deaccelerates back to rest. That's another common one. These are actually the two most common ones. So we'll have a look at an example now with problems. Do you need me to go back up to write this down?
Yes. Yes.
Sorry. Area is equal to slope, yeah?
Area is equal to the distance.
And slope is equal to
Yes. Yes? Okay. So the key ideas are, on the x-axis is what?
Speed.
No, on the x-axis time. On the y-axis, the uv velocities. The slope represents acceleration and the area represents distance.
Distance.
That's all the information on the graph. Let's have a look at an example. So I'm going to do as an example question 1 here, which I'll give to you in a minute. So I'll write the information down for you. Example 1, a car accelerates from rest to speed v in t1 seconds. It continues at this speed for t seconds, so continues at v for t seconds, and then deaccelerates uniformly to rest. So then it goes from v to rest in t2 seconds. And we're also told that the average speed equals 3/4 V. So you have 4 pieces of information. Let's have a look for this one now on the graph. So if I draw the graph here, it starts at rest and it goes up to V. It continues at this speed and then it deaccelerates back down at the end here. This time here to here is T1. This distance here to here is, how big's this one?
T.
T. And then the last one?
T2.
T2. Now, average speed is 3/4 V. What's our formula? Remember, distance equals average speed multiplied by time. So therefore, the average speed is equal to, you could say, distance over time if you wanted to. But anyways, we'll look at that in a minute. From this graph, let me get the area. What's the area here? A half? Yeah, it's going to be 3 shapes.
Yeah.
So what's the area of the triangle? A half
T1.
T1 multiply
T by
V plus
T.
T V. That's this one. And now this one plus a half
2T.
T2 V. That's the area. But what does area equal?
Distance.
Distance. Distance. Okay? But if you just look here, if I divide distance by time, what do I get? Average speed. So I'm going to divide this by the total time. So distance over total time. I need to divide this one now. What's the total time? No. Yeah, T1 plus T plus T2. So the distance over the total time, what did we say that is? That's the average, what's that? Average speed. And I tell you the average speed is 3/4 V. Now that's good because what happens to the V's? These all cancel.
Okay.
Yeah? What do you mean how? I divide everything by V.
Okay.
So I'm left now with, and actually I don't really want these halves here, so I'll multiply everything by 2. So I get T1 plus 2T plus T2 all over T1 plus T plus T2 equals 3/4.
Sorry, over 2.
Sorry, 3/2, because I multiply this by 2 and this by 2. Okay? Now, let's see, I need to go to a new page, but I'll scroll up now, okay? So I have a feeling people need to write this piece down, right? So go ahead and write it down. So my example here is very similar to the first question, but I'm going to do something different so you still have the first question to do. So I know you'd be disappointed if I did the first one for you because that would mean there's one less question for you to do. So I'll do a different part to what's in your worksheet for the next one. So what I'm going to do next, I'm going to find out how much of the time is spent traveling at a constant speed. So in other words, how much time is spent traveling in the flat piece in the middle. Now, you might say, well, that's going to be very difficult because if I look at this, I'm trying to find what this t is. I want to find the time. My question is, how much time is spent at speed v? So in other words, I'm asking you how much time or how much the journey is spent in this piece. So what am I looking for? T. Let's try to simplify this. So I can say that's T1 plus T plus T2 plus T. What did I do there?
T1.
T1, T and T2.
Can somebody tell me what I did going from here to here?
You move the T
I changed this 2T into
T
put it T plus T. Now I can split this into T1 plus T2 over T1 plus T2 plus, so what I did was I put these three together here, and I'll put this one separate here.
Why?
You'll see now.
Okay.
What's going to happen? Well, you can tell me what happens here.
Cancel.
Cancel, what do you get? One.
T. Just
No, here. One. Plus T over...
T1, T.
But rather than write T1, T... what does this represent, this T1, T2? The total time, yes?
Yeah.
So I'll just write total here for short. Equals 3 over 2. If I take the 1 over here, 3 over 2 minus 1? No, come on. 1.5 minus 1?
1 over
Half. What does this T represent?
T.
The time spent traveling in the middle.
Yes.
And what does this represent? The total. So if I say this is equal to a half, what am I really saying? The time spent traveling in the middle is half the total. Because look, T equals a half times total. So the answer is 50% of the time is at V meters per second. Now, I'm sure you want to write that down. So I'll go back up to here. Yes?
No.
Further?
Yes. Go on. Go on.
No.
That's it.
This is the best I'll do for you.
No, a little bit. Yes. Not used to me. It's a difficult one. Since we were invited, you go ahead.
Why didn't cancel the T from the beginning?
Which T?
Like in the next step?
Are we talking here?
Yes.
Why didn't I cancel what?
T1 with the T1.
You can't do this, Mohammed. You can't cancel this T1 with this T1.
Because you need to hold that.
It needs to be like this. T1, X, T1, Y, then you can cancel. You can't cancel if they're added. You can't cancel those ones.
One question.
They need to be multiplied, not added. Yes?
When you divided V by both sides, why isn't it divided by the distance over time?
This one here,
Yes,
I divided both sides by the total time.
yes.
That's this here, and this here.
When you go down.
I just wrote time here for short. If you want, that's total time. What are you asking me? No, seriously, what are you asking me? Because I'm confused.
I was asking about week, when you divided week.
Oh, when I cancel the v's here.
Yeah.
Yeah, so if you have like ax plus bx equals cx, you can divide everything by x.
Yes.
Yes?
So what about the distance over time? Is that just like you wrote for fun?
This here is equal to this.
Yes.
And I told you in the question that distance over time is average speed, which I told you is this.
Yes.
So this here, if you want to think about it, is the same as this. So if you prefer, you can make this on two lines, and on the second line, it will be exactly the same, except this gets replaced by this.
Can you go down?
Okay.
Go further down a bit more.
What?
Okay, we can cancel T with a T.
Which two? There's many T's. Am I looking at this line?
Yeah.
Which T?
No, that.
Oh, again.
No, here. Oh, this one.
Right.
Is it T1 plus T plus T2
Plus
T?
two. Yes.
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 Cancel again.
Which this T and this,
When we make it there for a V.
this T and this T?
Yes.
No, they can't.
But
What's,
in the
yeah, that's because V was on everything, on both sides. That's because the V was like this, AB plus BV, BV equals CV. There's a V in every single thing. There's only a T here and here, only in two places. It's not here, it's not here, and it's not here. So it needs to be in everything.
First one? Yeah, first one, second. I don't know what's mean. It means we found the time or the mean was yeah, you see second. No. It means we found the T or something.
English,
I asked him how to say how we're going to do one.
this one here, from this.
No, I asked him the result, how we're going to have.
3/2 minus 1
Yeah,
is a half.
Okay. So the one is from this one.
Yes, that's why I have a big arrow here. Came over to this side.
So cancel. Done. How do you do it like that? Like take these and
Yeah, what exactly is happening here? And I'll put it as fractions for you. If you have A plus B over C, if you wish, you are allowed to write this as A over C plus B over C. So essentially that's what I did. I split these two. This is like the A, so to speak, and this is like the B, and this is like the C, and I split it like that. The reason I did that is because I saw an opportunity to cancel this into one over here.
yeah.
That was the reason. That actually is a common trick when you're talking about trying to find the time in the middle piece. So it's possible that you will see, actually I'm certain that you'll see this trick again in another question. Okay, so it's not necessarily the only time you'll see it.
So the last bit, T is equals to half.
The total time.
Yes.
So in other words, 50% of your time is spent traveling at this constant V.
But we still don't have the time.
No, sometimes it's not possible to find the actual time in seconds, And that's why they often would ask you something like, how much of the time is spent travelling as a fraction of the total time? So no, you're right. I don't think there's enough information here because they don't tell me what the V is. They just say it's V. I have a feeling that if they tell me what the V is, then it maybe is possible, but still, I think it'd be maybe too difficult, maybe not possible. Yeah, so I don't actually think it's possible. Okay. So the first question on the worksheet I'm going to give you is going to be very similar to this one here. Now look, what's really important about these questions is that the question asks you to draw the graph. So once you have the graph drawn properly, it will help you a lot to get all the information out. Like for example, once I drew this graph,
Yes.
how did I find the distance? By finding the, what's this called? Area. So that gives me my start here, okay? So I think for a lot of these questions, a good start is to find the area after you draw it.